Welcome to the Virginia Education Center for Asphalt Technology. My name is David Lee. I'm with the Virginia Asphalt Association. And this module today we're going to talk about surface preparation as part of the Asphalt Field Level 1 school. For learning objectives today, let's talk about drainage considerations and how they create lasting pavement structures. We'll talk about understanding the steps involved in preparing the base and the existing pavements for overlays. And we'll also try to understand how base properties impact those paving decisions. So each one of those steps are critical to ensuring that we have a successful final pavement structure. First and foremost, I want to talk to you a little bit about drainage considerations. Drainage considerations are one of those things that seems to be overlooked many times, but is probably one of the most, if not the most, critical element to a long-lasting pavement structure. In the slides you see in front of you here, there's a project that was built, and it was built appropriately. It has a drainage structure there that it actually is an underdrain that's part of that pavement structure, and it's designed to drain the pavement so that anything that's down in below the pavement structure, below that surface, actually is drained out through these drainage structures. So you need to keep roadside drainage clear. Those systems have to be clear, all the vegetation that can build up in those. And so it'll allow the rainfall to quickly be carried away from that pavement structure. So if you don't, then you've gone through the trouble and the expense of ensuring that you've designed and built a project that should last a long, long time, because it will drain that pavement structure, get the water out from below that pavement structure. But if you don't maintain it, then it won't last. The picture you have in front of you here is actually a project that was built, and they went out to finally clear these drainage structures. Took a little longer than it should have, but you can actually see how much water is in that ditch line. That was actually, the vegetation was cleared from those finally, and it actually started to drain, and it drained a tremendous amount of water from that pavement structure. You can imagine if you don't do that, then that water becomes trapped under that pavement structure and actually can make the condition worse rather than make it better. So let's keep those drainage structures clear. First and foremost, it was designed correctly, so let's maintain it correctly. Proper crown and slope on a roadway. It's extremely critical. You can see in the picture below you that you have ponding water sitting on the pavement structure. Not only can this be hazardous to the traveling public, because they could hit large segments of that in hydroplane, but it is very poor practice when it comes to ensuring that you maintain a good pavement structure. Effective crown and adequate slope is to ensure that rapid transmit of the water off the pavement. Again, not only helps the traveling public to ensure a safe pathway, but it gets that water away from the pavement structure and away from that pavement surface. All pavements will have some cracking in them, so that water can penetrate through those cracks if it's not allowed to get away from the surface as quickly as possible. So the proper crown and slope on a roadway is absolutely critical. It's not only critical that it be built correctly, but it's also critical that we try to maintain a proper crown and slope on all of our roadways during the maintenance activities, so that we don't take a roadway that was originally designed and built with a good proper crown and slope, and then somehow, because of our paving operations or because of how we've had to tie into certain new structures or to new intersections, now we lose that crown and slope and the water can't get away from the pavement structure. So during our maintenance activities, it's just as critical as it was when it was built, that we try to ensure a proper crown and slope on our roadways. Here's an example of curb and gutter elevations. It's obviously critical that that curb and gutter be built where it's designed and where it will carry that water and transmit that water away from the roadway. Again, the same purpose is there to get the water off the roadway, make it a safe travel way so the traveling public will not hydroplane or have tremendous amounts of water that stand on the roadway. But it's also just as critical for the maintenance of that roadway. So you can see in these two slides that the actual asphalt pavement didn't come all the way up to the top of that gutter pan. Well, when that occurs, the water can't obviously get away from the roadway. So what happens is it starts to saturate the pavement structure, and it gets down below that surface asphalt, gets all the way down into the subbase and the base portions of this pavement structure, and they begin to deteriorate. The picture on your left, you'll see, actually is deteriorated to the point you have severe alligator cracking and you have a structural failure at that location, purely because the water was not allowed to properly transmit away from the pavement structure in this case. So not only do you have an unsafe condition, but you have a condition that has allowed a segment of pavement to deteriorate rapidly when it could have lasted a long time. Picture on the right, fairly newly constructed, still not matching the top of the gutter pan. That needs to be corrected and needs to be corrected immediately so that you can ensure proper drainage away from the pavement structure. Here's a video I wanted to show y'all on a construction project that was built a few years ago. And unfortunately, when the contractor came out there, he noted that the subgrade in there was just a little bit too wet. The moisture conditions were too high, but this was a segment of the roadway that needed to get open to traffic. They were trying to do a traffic shift, so they said, we've got to get in there and pave it, recognizing that they didn't have the best conditions. So you'll see in the video that once they got that done and they came back out there the next morning, they were actually able to step on this, and it was so saturated and the water got trapped in that location so badly that it actually moved under their feet. And you can see the water start to pump up through the pavement structure itself, and it stands on the pavement structure. What did they have to do? Well, they had to redo it. They had to start all over again. They had to close that lane back down. They had to repair the subgrade. They had to make sure they got the water out from underneath that pavement structure, reconstruct that segment, and repave that whole segment. So in this case, while you can understand why they were in a critical moment where they needed to make a shift, the decision to go ahead and pave that segment wound up costing them not only time, but it cost money. So in the end of the day, best thing to always do, of course, is to try to get it built right the first time. When you note these types of problems, you stop and you get them fixed immediately. It might cause a slight delay at that moment, but at the end, you're not having to repeat that whole process. So here was a situation where drainage became a problem, and it created problems as it was being constructed, and they had to reconstruct that whole segment. So recognize you can't always, get things fixed immediately. You got to stop for a second and fix what's there and then start the process all over again. So let's talk now a little bit about crack sealing or filling of cracks. So that's performed sometimes whether you're doing an overlay or not. Sometimes you'll do crack sealing on a roadway purely as a maintenance activity. You catch the pavement early enough, you try to get out there and seal the cracks so that that pavement will last longer. Sometimes crack sealing is actually performed just prior to an overlay. So you'll go out there and seal the cracks, and then you'll overlay that. There's enough cracks to where you feel like they need to be sealed, but not enough to actually mill the roadway. You're just going to perform an overlay, so you'll do crack sealing for that. Most of the materials that are used for crack sealing are a rubberized type of crack sealant. They're an asphalt binder, and some of them actually have polyester fibers. But most of the crack sealing materials that are used today, and VDOT requires when they do crack sealing on their projects, those types of crack sealing materials are built to last long when they're applied correctly under the cracks that are there. And they're usually used for cracks that are widths between that 1/8 of an inch, maybe up to 1.5 inches. 1.5 is pushing the limits of how wide a crack should be when you're doing crack filling or crack sealing. Because as you get wider, you can imagine that becomes more difficult for that material to actually adhere and to maintain a sealed condition that when it's that wide. So you're trying to keep cracks that are fairly small and try to catch them as early as you can when you do crack sealing. Here's a picture that shows obviously a pavement that had a lot of cracks. This would be one that I would tell you that probably was beyond its path for crack sealing. There's a lot of crack sealing. The cracks that are on this roadway are frequent and they're real close together, and so the pavement has deteriorated beyond its life and needed to probably be milled and replaced as opposed to actually trying to fill those cracks with crack sealing. The pavement's already starting to crack to such an extent that just doing this types of crack sealing is not going to allow it to perform longer, and in the end you likely just wasted the money that you used for that crack sealing. Crack sealing can be used appropriately though, so recognize that in many instances if you have roads that are cracked, not nearly as severe as this one, crack sealing is a proper maintenance activity prior to an overlay or just for sealing the cracks whether you're overlaying or not. Okay, let's talk a little bit about that base preparation for our new pavements. I talked about a minute ago and you showed you that slide where that pavement pumped the water out of it. We're trying to avoid that, right? We want to build a pavement structure that has a good foundation. That foundation, subgrade material, base layer material, has to meet all the specifications prior to ever getting to put any asphalt overlays, whether it be the base that goes on top of the subbase, or it be the subgrade itself, where you're trying to actually ensure a good, strong foundation for the pavement structure. That subgrade soil, that granular base, all of those have to actually meet the requirements that VDOT has for moisture, density, structural strength. They got to have that grade we talked about. You got to have the crown and the slope properly, and it has to be uniform throughout its section. Sometimes a prime coat. We'll talk a minute about prime coats, but again, I want to point out to you that it's very critical that we ensure that this foundation to our asphalt pavements is built correctly. Because if it's not built correctly and you don't have that foundation, it's just like your house. If you don't have a good foundation under your house, then your walls are going to crack. If you don't have a good foundation under your pavements, then your asphalt surfaces and so forth will also crack. Okay, prime coats. Prime coats are something that we used to talk about a lot, and we used a lot over the years. We used prime coats on almost all projects, say 20, 30 years ago. Now they're a little more specific, but prime coat is basically an emulsified asphalt. Sometimes it's a cutback asphalt, but we see fewer and fewer uses of actual cutback asphalts. Cutback asphalt being one that actually uses naphtha, whereas an emulsified asphalt uses water to actually break that asphalt. It's applied to the aggregate, soil or soil cement, sometimes cement stabilized subbases, so that you can ensure that it's not only sealed, but that you can sometimes get a better bond to the layer above it. But it's only required right now in VDOT specification requirements for asphalt treated open graded drainage layers. That is required in the specifications. You put a prime on those layers prior to putting the asphalt treated open graded drainage layer, or wherever it's specified in the contract. So you'll have a contract specific to your project, or you'll have a set of plans specific to your project. If it states in that contract or on those plans that a prime is required, then obviously it's required for that project. Otherwise, prime coats are not required on any of VDOT's work. Let's talk a minute about the preparation of existing surfaces for asphalt overlays. Most of the activities that occur around the state are maintenance activities, and those are typically either asphalt overlays, or sometimes we'll talk a little bit later about milling, but sometimes we'll mill the existing pavement. But if we're doing an asphalt overlay, that is our typical maintenance activity. We will overlay an existing pavement to ensure we get a long life pavement structure. But we may have to patch that roadway. So we got to ensure that we do a proper asphalt patch on these roadways. One of the most critical elements of doing that is ensuring that you obviously remove the deteriorated material from that pavement section. That section might very well need milling. You may actually have to patch a small area where you have to cut that section out, or you may actually have to go in and mill large segments of the roadway so that you can take out a whole segment that's deteriorated beyond its life. And those are usually determined in the contract. You'll find those and tells you exactly where and when you need to do that. But it's critical that we ensure that we get the deteriorated pavement removed prior to putting an overlay on. If you're doing a patch, you're going to square up those sides. You can't go out there and do a patch that has these random edges on it, because it's not only difficult to get proper compaction in that patch, but it's also difficult to ensure that you get good sealing, because that patch has to also seal so that water doesn't get down into that existing pavement and allow further deterioration. You have to tack. We'll talk later about tack, but tack is something that's absolutely critical to ensure that you get not only a good bond to the layer below, but you also get it sealed up real well again so that water doesn't penetrate into that patched area. And you're going to lay the asphalt and compact it. Sometimes you have to do it in multiple lifts, so your patch may very well be a fairly deep patch. So you'll have to go in and place those asphalt layers in multiple lifts as opposed to just one lift, so you can ensure you get good quality patches that have proper compaction and proper density. So sometimes you're doing an asphalt over an asphalt type of repair. And those patches are obviously just as clear as you think they would be. You're repairing an asphalt pavement with asphalt. So that asphalt pavement is being replaced and it's being patched. You may very well do some crack filling on that. So you may have a segment that you can do some crack filling, and then you may come back to do some scratch and leveling courses to ensure you get good uniformity and a good ride, and also a good cross slope. Sometimes you have to do that scratch and leveling course to make sure that as you repair that roadway, that again, going back to our drainage discussion, that you can actually get that water away from the roadway, you get that proper crown and slope, you ensure you have a uniform layer for that overlay to occur on so that you can get good uniform density on your overlay. And then lastly, you might do milling. Milling is something that's used a lot because it's fairly efficient. It removes obviously all that deteriorated material, and you can get it done in such a way that it expedites the project very quickly, and the millings can be hauled away and you can get your patch in very quickly. There's things such as milling heads on bobcats, and then there's large milling machines for larger type patch. Sometimes you got to do asphalt over concrete. So we have in Virginia a number of roadways that are concrete roadways that actually have asphalt over top of them, and those have to be patched. And you'll see severely distressed areas in those concrete slabs. Just like the asphalt we talked about a minute ago, you've got to cut that deteriorated area out. You've got to remove that deteriorated area. You may have a corner break in the concrete pavement below. You've got to get down to that concrete, remove that segment that has deteriorated, and patch that. You may patch that with Portland cement concrete, or you may patch that with asphalt. VDOT's requirements allow both, and you need to look at your specific contract to ensure you do it in accordance with that specific project. But you can patch that roadway, you must patch that prior to actually getting that overlay on there. So in this case, you've got a concrete pavement and you've got a full depth slab that has to be repaired. So you go in and remove that full depth segment out of that concrete pavement. You patch that, again, you either patch it with Portland cement concrete, or in most cases they do now with asphalt. And then you can come back with your asphalt overlay to ensure you get it done in such a way that that asphalt overlay will last. I talked to you a minute ago about a little bit about scratch and leveling courses. Scratch and leveling courses are probably underutilized, but scratch and leveling courses are very critical to ensure that we get a correct surface irregularity repaired. Sometimes we have ruts, we have dips, we may have bumps. We need to get that scratch and leveling in there to ensure we have a uniform surface to put our final overlay on. So it's critical that in many cases we back up and we say, okay, we've got ruts in this case. I need to come in and I need to pull a scratch or a leveling course through these ruts to ensure that I get these in such a way that my final overlay will be a uniform depth so that you can get proper density and you'll have a long-lasting overlay. In many instances, you may very well mill, but if you don't have milling, scratching and leveling courses are the best way to make sure that you correct that cross slope. So you may be on a rural route that doesn't have a real good cross slope. We talked about drainage. Drainage is critical, so you got to make sure you get that water away from the pavement structure. Scratching and leveling allows you to go in there and place a scratch course in such a way that you can actually build that crown back up in the roadway so that you can get the water off the roadway properly. So it's critical that you ensure that you get that. So you don't want those variable depths for that final overlay, and you want to be able to put lifts in such that the asphalt leads to, so it doesn't lead to a differential compaction. That's critical that we ensure that we get that final overlay in such a way that it's uniform and we can get good quality compaction in that overlay. Scratch and leveling courses are one of the many ways that we can do to ensure that we get that. Here's a picture that shows a scratch and leveling course. I might argue that this pavement's probably getting close to being ready for actually a milling operation. However, you'll see they've placed the lift on the other side of the roadway. It looks very good. It looks uniform. It's been done correctly. The scratch and leveling course has allowed them to place that in such a way that they get that crown and they slope back so that the water will get away from the roadway. And this is exactly what a scratch or a leveling course looks like. You can see they actually pull it down to a fairly thin lift so that it actually just fills the areas that need to be filled. It builds up the areas that need to be built up, and then you can place your final overlay on top of that. So in summary, surface preparation is critical. Water can be just as destructive as a tractor trailer in this case. So if you're out there and you allow water to get on the pavement and stay on the pavement, saturating that pavement, it's just as destructive as a heavy truck that's 80,000 pounds going across that pavement structure. So you got to provide a surface and subsurface drainage. As we showed earlier, that surface and subsurface drainage is critical to ensure that you maintain a good foundation to that pavement structure. If you allow it to get saturated, then it loses strength and that pavement structure will fail. Asphalt materials that are needed for a sound and stable platform. We got to ensure that we have that platform correct so that when we place that final overlay, like we talked about, that it's uniform, it has good density, and it'll last a long, long time. Cracks, potholes, and other distresses have to be repaired prior to paving. All too often, we find ourselves out there and we get in a rush and we see a spot that clearly needs to be repaired, and we pave over top of that. And what's that going to do? That's going to come back very quickly, and it's going to require you to get back in on that segment of pavement and repair it later on. So it's critical that we ensure that we patch our roadways correctly, we do crack sealing where it's appropriate, we do scratch and leveling where it's appropriate, and we get that final overlay on top of it so that it'll last a long, long time. That's the end of this segment. If you have any questions, please submit those to your proctor, and I'm sure they'll get back to you as quickly as possible.